So here we are at our key features of graphs, and it's super important that we understand all of these working parts because we need to be able to read and interpret the graphs we're getting. So let's go back for a second and review. The definition of a function is where every input corresponds to exactly one output, meaning x can't repeat. And remember, we can use a vertical line to determine if the graph is a function. So if I were to take my pencil, so take this, and move it back over, we'd see that this is in fact a function, and it's a linear function, okay? So I put my line here so that you can see. You could move this blue line anywhere. And remember what we said in class, we're not actually drawing that line, but so that you can visually see it, it touches there in one place. So let's try this. Use the vertical line test to determine if the following graphs are functions. So you go try that now. Okay. So on the first one, it hits that blue line in two places. Therefore, it is not a function. Now on this one, if I were to take this and move it anywhere I move this, it's only going to touch at one point. Therefore, this graph is a function. So what about these? Take a minute and read what it says, and I want you to answer this question. Which of the following graphs represent functions? Select all that apply. Okay, so here we have a linear function. Then as we move through, our next function's not till we're down at the bottom. That's a horizontal line, but that is a function. This is an absolute value function, which we're not going to get into too much this year. You might see it and have to interpret it, but you don't have to graph it. You can by making a table. Next, this is actually an exponential function. Okay, that's what the graph's going to look like. So if you've been listening to any of the COVID data and you see any of the graphs, what's happened here is the spread of COVID's happened exponentially. And then last, we have a quadratic function, and we're going to spend 2 units on that. Okay? So now let's take our understanding of functions and look at a real-world situation. So we're going to determine if this creates a function. And remember, in a function, our x value cannot repeat. So we're looking at our independent variable in this situation. Could it repeat? So let's look at letter A. An analyst takes a survey of people about their heights and their ages. So those are our 2 variables. She then relates their height to their age. So let's think about this. When you relate the height to the age, it's not a function because our age is our independent. We are relating, we are being given our age, and we're trying to find a relation to its height. Well, when you go and survey people, couldn't someone be the same age? So since our age was our input, ages could repeat. Heights could repeat, but remember our output doesn't matter. So in this example, it is not a function. Okay? So let's look at B. A geometry student is dilating a circle. Dilating means making bigger or smaller. So we're changing the size of our circle. And in that process, they're analyzing the area as it relates to the radius. Well, let's think. When I change my radius, which I'm looking at my radius, I'm relating it back to the radius. So therefore, my area is going to be an outcome of whatever my radius is. So my radius is my x and my area is my y. But think about this. Would you have would your radius repeat? No. If you have a radius of 15, it's going to have a set area. You're not going to have a different circle with a radius of 15 and a different area. So this one is a function because Each radius will result in a specific area. So let's go look at C. A teacher has a roster of 32 students and relates the student's letter grade to the percent of points earned. So we got to look at this carefully. It's the percent of points they get. So if you get an 80, if you get an 85, if you get a 90, relates to their letter grade. So if someone gets a 90, okay, that is your X. That's what they're getting. They get the points earned, they get a 90. Well, then that transfers into their letter grade. So if Allison got a 90 and Joey got a 90, they're both going to get A's, right? So it's got a specific output. You're not going to give someone a 90 an A and then someone that got a 90 a B. So there is a specific output for that specific input, and it's only one. So that therefore it is a function. Okay? Last one is a boy throws a tennis ball in the air and lets it fall to the ground. The boy then relates the time passed to the height of the ball. Okay? So think about this. What do we have here? Well, as time passes, the height of the ball is going to change. You can't keep the same height over the same amount of time. So this one is a function. You'll only have a specific height at a specific time. Okay? So now we need to stretch this a little further. That's a little review of functions. But in a function, we have key features. We have something called the x-intercept. That's the point of the graph that touches and crosses the x-axis. So the y-coordinate of my x-intercept is always 0 because I'm not moving anywhere on my y. The y-intercept is the point of the graph where it crosses the y-axis. And the y-intercept always has an x-coordinate of 0. And we've kind of touched on this, but here it comes again, and this is what we've been saying. The x-intercept. Whenever you have a graph, the x-intercept is the solution to your function. That is the solution to the situation, and it's important that you understand that. So let's look here. This one says identify the x and the y-intercept from a graph. So remember, the x-intercept is the point where it crosses the x-axis. That is a specific point. So here, my x-intercept is 3, 0. Do you see how it says the y-coordinate is 0? Then my y-intercept is the point where it crosses the y-axis. And here, my x-coordinate is 0. So do you see the difference between your two coordinates? Okay. So let's look at this graph. This represents the height in feet a water balloon is dropped from a second-story window after a given number of seconds. So I can interpret a lot from this graph, and I can figure out a lot from this graph. So first, let's decide what's the x-intercept. Well, remember, it's the place where it touches the x-axis. And I see that's halfway between 1 and 1.5. So that means it's 1.25, 0. The y-intercept is the place where it crosses the y-axis. Okay, if I look at that, it's at 25. So I also can tell that my water balloon's being dropped from 25 feet in the air. Because if we look at it, it says the height, and that's its starting point. Okay? And then label your intercepts. So you would label here x-intercepts and then y-intercept. That's what it asked you to do. So ABC, doable, right? Well, let's go look at these. What does the y-intercept represent in this real-world context? And I kind of already gave you a hint of what I can figure out. Well, my y-intercept is up here at 25. What it's representing is the height from where the balloon was dropped. That is my starting point. Your y-intercept is the beginning. That's where you begin. It's the starting point of this graph, okay? So it tells me I dropped my balloon from 25 feet in the air. Now, what does the x-intercept represent? Well, look what happened with your balloon. It took that path, right? It's the number of seconds it took the balloon to hit the ground. That's what it represents, because it went from 25 feet and followed that blue path down. And where it ended, okay, was where it hit the ground. And it tells me how long it took. So the solution to this situation, remember the solution is your x-intercept. What that means is it took the balloon 1.25 seconds to hit the ground. And I know it's seconds because I read my chart and my graph and it said time in seconds. Okay? So a couple more key features to look at. What's your domain? We've already talked about that. That's the x values, your input. Your range is your output, the y values. Now an increasing interval. So this is an interval on your graph, so a place in the graph where as the x value increases, the y value increases. So we're going positive in both directions, okay? A decreasing interval is where the x values increase and the y values decrease. With me so far? Now, a relative maximum. So think about what a maximum is. Okay, it's the point on a graph where the interval changes from an increase, so we're going up, to a decrease, and then we're going to go back down. So think about when you're throwing a ball in the air. It's going to eventually hit its highest point, but then it's got to come back down. So your ball is increasing, it hits its maximum height, and then it comes back down and it decreases. Now a relative minimum is a point on a graph where the interval changes from decreasing to increasing, okay? Think about when you're going diving, okay? You're going down. Well, at some point, you got to come back up, right? When you're like swimming in a pool, you go down, you get something from the bottom of the pool, you're not going to stay down there. You got to come back up. So when you hit that bottom of that pool, that was your minimum, and then you're going to come back up. So let's see what that looks like on a graph. So we're going to identify increasing, decreasing, maximum, and minimum. So let's look at our most obvious interval. I can tell here that it's increasing, but it's increasing from point D, okay? So this stretch of E, that is actually where we're increasing. That is an increasing interval. So we would say that the graph increases where x is greater than or equal to 2. So when we talk about increasing and intervals, we're looking at the x value. So anywhere where x is greater than or equal to 2, my graph is increasing. Now it's kind of hard to look at, but think about how you read a book and how we read things. We read from left to right. So when we look at this graph and we want to trace it, I'm going to trace, do you see how I just traced it with pink? I went from left up. I always go from the left side up. Well, my graph is actually increasing over A. So that is an increasing interval. So here's how we say this interval is increasing. Where x is less than or equal to -2, my graph will be increasing. So whenever you have that x value, so if x is -5, it's increasing. If x is -20, it's still increasing. Because look, as my x value goes up, my y value is going up. So again, we're still tracing our graph from left to right. So as I move from B to D, my graph went down. My x values are going up, but my y values are going down. So this is a decreasing interval. So we got to be careful how we write this one. We're going to say that my graph decreases from -2 is less than or equal to x is less than or equal to 2. So from -2 to 2, my graph decreases. Okay? There's 2 more points here. We have a maximum point here at B. That is my maximum. The maximum point is negative 216, but the maximum value is 16. So I need you to write that. The maximum point is an ordered pair. The maximum value on a graph is the y coordinate of that point. Same thing goes for minimum. Look where your graph dips. Your minimum point is right here at D. Your minimum point is 2, negative 16, but your minimum value is negative 16. Because there's gonna come a point with this where it says, what is the maximum value of your situation? Or what is the minimum value you would have? So when you're talking about the value, you're looking at the y coordinate. So I want you to attempt this one. I want you to find the domain and range. I want you to tell me where the graph is increasing, where the graph is decreasing, if there's a maximum or a minimum. Remember, this is not a sprint, it's a marathon. We'll get there together with practice and perseverance. We're not expecting all of us to be masters night 1, but we need you to put forth effort and try. Put something down, okay? You might have to go back and re-watch this video, and that's okay. So if you did this and you watched all the way to the end, put a star at the top of the front page and you'll get an extra credit point.